This is number 3, right? Okay. So say we wanted to rewrite sine squared times cosine squared. Really, and I should very much get in a better habit of this because I do occasionally see you guys doing this kind of thing that I just said. So why is the thing I just said not quite correct? Yeah, you really should read this as rewrite sine squared of theta times cosine squared of theta in terms of cosine of 2 theta and constants, right? So I often get in the habit of dropping the argument of the function that I'm talking about. And I noticed that some of you guys have gotten in that habit too. When you say it, I'm okay with that. When you write it, I am not. Okay? So don't give me stuff like cosine equals. There needs to be a thing here. Cool? All right, that's my rant for that one.
I noticed I did that for some of them and some not others.
Yeah, it's. I think at least a little bit of it is just flat panic, and that's kind of okay. Or you've gotten to the end and you know you're doing things right, so you just like move on quickly. It would be good if we could get in the habit of like going back and read carefully. So I'm going to try to exhibit that up here. So how do I rewrite this? What do I start with? Oh yeah, you did that. That was nasty. Don't do that. It's horrible. It's not wrong. It's just horrible.
You like bust out the modelers.
What about double angle or?
Yeah, I would bust out de Moivre's only to go find the double angle identity. So I think I want the double angles, and so those are me thinking, right? There's sine squared, so now I want to rewrite as cosine of 2 thetas. Yeah. So I know a thing that does sine squareds and 2 thetas. That's 1 minus cosine of 2 theta over 2. And the one for cosine is cosine squared of theta is 1 plus cosine of 2 theta over 2. So this should, if you saw this trick, this is pretty easy because you just replace sine squared of theta with 1 minus cosine of 2 theta all over 2. And you replace cosine squared with 1 plus cosine of 2 theta all over 2. And then actually, yeah, you could be done here. I think I was more happy if you multiplied this out a little bit, unless you did it wrong, in which case I was less happy. So the bottom's 4, right? And the top is the top is difference of squares. You guys see that?
Yeah, that crap I never learned.
That crap you should know.
Yeah.
No. Well,
So I got 1 minus cosine squared of what?
2 theta.
Of 2 theta. You guys see that? That's the frickin' last term of this thing times the last term of that thing, right?
Okay, so it's the
So
cosine
that's
circle squared.
This guy is cosine of 2 theta times cosine of 2 theta. Right, so it's just the cosine bit that's squared because the 2 theta is the thing you're doing them both to. I realized that was tough. So a lot of you guys made that little error. That's maybe okay-ish. The thing I want you to note, right, is that this whole object is a function of theta, and this whole object is the exact same thing. So there are 2 of those multiplied together. Guys cool with that? All right. And then, yeah, you could make a bonus point if you applied the half angle formula again. But whatever. I think only Joe did that. He's not here. So. Cool. Questions, Steele?
Oh, thank you.
Joe, the guy who sat next to you all semester?
Yeah.